Have you ever looked up at the night sky and wondered about the secrets hidden among the countless points of light? Most stars we see are young and vibrant, but some are ancient travelers. One such traveler is Captain's Star, a mysterious, elusive object that has journeyed through galaxies to end up in our own cosmic neighborhood. It's not the brightest or the biggest star out there, but its story is one of the most fascinating. It's a phantom from another time, a ghostly remnant of a galaxy long since devoured by our own Milky Way. And it beckons us with questions about the very origins of our cosmic home. Captain's Star is a red dwarf, smaller, cooler, dimmer than our own sun. Located a mere 12.8 light-years away, in the southern constellation of Pictor, it is one of the closest stars to our solar system. It was discovered in 1898 by the Dutch astronomer Jacobus Kapteyn, who noticed its unusually high proper motion. This star is zipping across the sky faster than any other star visible from Earth, a clear sign that it's just visiting and not originally from around here. Scientists believe Captain's Star was not born within the Milky Way. Instead, it likely originated in a dwarf galaxy that our own much larger galaxy collided with and absorbed billions of years ago. The star was ripped from its home and now orbits the Milky Way in the opposite direction of most other stars, a lonely traveler on a retrograde path. This makes it an incredibly valuable object for study, as it's a living fossil from a galaxy that no longer exists. It carries the chemical signatures and history of its lost home, offering a direct window into the violent and dynamic past of our galactic environment. Its journey through space is a testament to the grand and often chaotic dance of galaxies. Captain's Star is one of the survivors of such a merger, a piece of debris left over from a galactic collision. Its unusual orbit and ancient age, estimated to be around 11.5 billion years old, make it a subject of intense scientific curiosity. It's a quiet witness to cosmic history, silently orbiting right next door. Now let's embark on a journey of pure imagination. What would happen if you were to find yourself falling into Captain's Star? The experience would be nothing short of terrifying and awe-inspiring. Your journey would begin far from the star itself, in the cold, silent vacuum of space. As you drifted closer, the faint cherry-red dot would slowly grow, transforming from a point of light into a massive burning sphere. The first thing you would notice is a gentle warmth, a stark contrast to the biting cold of deep space. This warmth would steadily intensify, a prelude to the inferno that awaits. As you plunge deeper into its gravitational pull, the star would fill your entire field of view, a swirling cauldron of crimson and orange plasma. The temperature would rise exponentially. Your protective suit, if you had one, would begin to glow, its outer layers superheating and vaporizing under the relentless thermal radiation. You would feel the star's immense gravity tugging at every molecule of your being, accelerating your descent into the fiery abyss. The very fabric of space-time would feel warped around this dense, ancient object. It's a one-way trip, an inexorable fall, toward a destination of unimaginable heat and pressure, where the laws of physics as we know them are pushed to their absolute limits. The next stage of your fall would be a battle against the star's own atmosphere, its corona and chromosphere. Long before you reach the visible surface, you would be engulfed in superheated gases, a turbulent sea of plasma reaching millions of degrees Celsius. Any physical object, including a human body, would be torn apart atom by atom. You wouldn't burn in the conventional sense, you would simply cease to exist, your constituent particles stripped away and absorbed into the star's roiling mass. The sheer force of the solar wind, a stream of charged particles erupting from the star, would act like a cosmic sandblaster, eroding you into nothingness in a fraction of a second. Finally, what was left of you would reach the photosphere, the visible surface of Captain's Star. Your atoms, now part of the star itself, would be crushed, fused, recycled in the nuclear furnace at the star's core. Your journey would end not with a splash, but with a complete and total assimilation into the heart of a cosmic relic. To truly appreciate Captain's Star, compare it to the star we know best, our Sun. The differences are striking. Our Sun is a yellow dwarf, a medium-sized star in the prime of its life. Captain's Star is a red dwarf, the most common star in the Milky Way, but too dim to see with the naked eye. Most obvious differences, size and temperature. The Sun's diameter is about 1.4 million kilometers. Captain's Star is less than a third that size, much more compact. The Sun's surface is around 5,500 degrees Celsius, giving it a brilliant yellowish-white glow. Captain's star is about 3,500 degrees Celsius, which is why it shines dimmer and reddish. If you placed Captain's star where the sun is, Earth would become a frozen wasteland. The habitable zone around a red dwarf is much, much closer. Any planets orbiting Captain's star would need to huddle close to stay warm. Perhaps the most dramatic difference lies in their lifespans. Our sun has been burning for about 4.6 billion years and has about 5 billion left. Then it will swell into a red giant and eventually fade as a white dwarf. Red dwarfs are the marathon runners of the cosmos. They burn fuel slowly. Their lifespans are measured in trillions of years. Captain's star is already about 11.5 billion years old, yet it's still in its infancy and will shine long after our sun is gone. That longevity has profound implications. Our sun will one day destroy its inner planets. Red dwarfs, by contrast, provide stable, long-lasting energy. 2 planets have been discovered orbiting Captain's star. One, Captain B, is a super-Earth in the habitable zone, making it one of the oldest known potentially habitable planets. It's a tantalizing prospect. Life could have had billions of years to emerge and evolve there.
अरे भाई 1 लाख का ट्रेड। कल तो तू कह था तेरे पास सिर्फ 20,000 रुपए हैं। कोई लॉटरी लगी है, किसी से उधार लिया है?
कोई उधार नहीं लिया भाई। मैंने आईडी मनी का 5x वॉलेट बूस्ट यूज किया है, जिसकी वजह से मुझे 20,000 रुपए में 1 लाख रुपए तक की ट्रेडिंग पावर मिल गई।
क्या बात कर रहा है यार, ये कोई भी यूज कर सकता है?
हाँ, तू भी कर सकती है। उसके लिए पर तेरे को आईडी मनी ऐप डाउनलोड करना पड़ेगा, और आपको भी।
Investment in the securities market is subject to market risks. Read all the related documents carefully before investing.
प्रो इन्वेस्टर्स के लिए, न्यू इन्वेस्टर्स के लिए, एंजल वन फॉर एवरीवन। 3 करोड़ इंडियंस की तरह आप भी शुरू कीजिए।
Angel One for everyone.
Investments in securities market are subject to market risks. Read all the related documents carefully before investing.
There. Let's push our thought experiment further. Imagine a hypothetical spacecraft built for the impossible, carrying you perilously close to Captain's star. What would you see and feel? A complete sensory overload. A symphony of cosmic forces no human has ever witnessed. As you approach, silence gives way to a low, pervasive hum through the hull. The vibration of the star's immense energy. Light is not white but a deep penetrating crimson, painting your cockpit in shades of blood and fire. Heat floods in, oppressive warmth even through advanced shielding. Cooling systems scream and groan, pushed to their absolute limit. Outside the viewport, the star is no smooth ball. A turbulent, churning ocean of plasma. Giant convection cells like boiling bubbles the size of continents rise and fall, casting shifting patterns of light and shadow. Magnetic activity dominates. Colossal stellar flares appear, arcs of plasma erupt and stretch for thousands of kilometers before collapsing back down. Eruptions unleash bursts of X-rays and clouds of charged particles, a cosmic storm hammering your shields. The spectacle is violent and beautiful, the engine of a star laid bare. Gravitational forces grow intense. Tidal forces try to stretch your ship as you orbit. Every maneuver demands immense counter-thrust. Look away, and the cosmos warps. Distant galaxies' light bends from gravitational lensing. Space and time itself feel distorted. It's humbling, terrifying, a reminder of our fragility and a privileged glimpse into a stellar furnace. The experience would be a complete sensory overload, a symphony of cosmic forces beyond human comprehension. Beyond the thrilling thought experiment of falling into it, Captain's star holds immense scientific value. It is, in essence, a cosmic time capsule. Because it is so old and from another galaxy, its chemical composition is very different from stars born in the Milky Way, with much lower concentration of metals. That tells us its dwarf galaxy was far less chemically evolved, a snapshot of early galactic building blocks. Studying its light gives us clues about conditions over 11 billion years ago. The planets orbiting this ancient star add another layer of intrigue. The discovery of Captain B, a potential super-Earth in the habitable zone, is particularly exciting. At an estimated 11 billion years old, it is more than twice the age of Earth. If life can arise on red dwarf planets, Captain B had a colossal head start. Could life have emerged and evolved there billions of years before Earth? Could it have become complex, or long since vanished? This system challenges our ideas of where and when life appears. Scientists study Captain's star using a variety of techniques, analyzing its light spectrum to measure composition, tracking its tiny wobbles to detect planets' gravitational tugs, using its rapid motion for measuring stellar parallax. Every piece of data helps refine models of star formation, galactic evolution, and the potential for life elsewhere. It's a nearby laboratory, a gift from a long-lost galaxy. Captein's star shows even unassuming objects hold profound secrets. It reminds us the cosmos is dynamic, and we're part of a grand story stretching back billions of years. The more we learn about stars like this, the more we learn about our own origins. The journey of discovery is far from over. I invite you to continue this journey of cosmic exploration, to discover more incredible stories about our universe and get access to powerful AI tools that bring these wonders to life. Visit my profile and click the special AI Media Machine link.
चाचू अब चार्ट्स देख रहे हो कि टेनिस?
पहले चार्ट फिर ऑर्डर फिर चार्ट, ऐसा ही होता है।
अरे ये सब आपके जमाने में होता होगा, आज के जमाने में ट्रेडिंग और एनालिसिस सीधे धन चार्ट पे होता है। ये देखो 100+ इंडिकेटर्स है और ऑर्डर्स सीधे चार्ट पे।
पर मल्टी चार्ट्स,
धन चार्ट्स,
ऑप्शन चेन,
धन चार्ट्स,
फोन पे ट्रेडिंग,
अरे धन चार्ट्स यार चाचू।
स्कैल्पिंग,
चाचू
धन चार्ट्स।
एग्जैक्टली।
छोटे तो बड़ा हो गया।
आई नो।
तो फिर तेरी रिश्ते की बात करें?
चाचू इतना भी बड़ा नहीं हुआ मैं।
धन चार्ट्स, जहां एनालिसिस और ऑर्डर एक ही प्लेटफॉर्म पे हो ताकि एक ट्रेडर कभी रुके नहीं।
धन है
तो डन है।
धन मेड फॉर ट्रेड।
Investments in the securities market are subject to market risk. Read all the related documents carefully before investing.
PhonePe presents Share.Market, a simple, smart, all-in-one app for your investments. Begin your journey to smart investments at just rupees 250. Download Share.Market today.
Investments in securities market are subject to market risks. Read all the related documents carefully before investing.
My journey began in the profound silence of interstellar space. Here distance is measured in light years, and time stretches thin. My destination? Wolf 359, a quiet red dwarf in Leo. The universe was an unchanging tapestry of distant lights, the silence overwhelming. My ship, propelled by curiosity, glided through the emptiness. The sun faded behind me, leaving me adrift in the galactic wilderness. Approaching Wolf 359, the darkness softened. A crimson twilight emerged. This star, old and patient, glowed with a subtle, enduring light. Its gentle radiance was a testament to cosmic persistence. The silence now held a faint, ruddy glow. Drawing near, the star appeared as a smoldering coal. No violent flares, just slow, churning convection. Its beauty was in its subtlety, a quiet strength. My long fall was nearing its end. The silent journey was about to get very loud. I was on the threshold of a new reality, where the void would soon give way to fire. The ember awaited. As I closed in, Wolf 359 transformed from a red dot to a world of fire. Its surface was a chaotic landscape of magnetic storms and flares, violent yet contained. The star's magnetic field reached out, a low hum vibrating through me. The light was a dim, pervasive red, alien, like a perpetual sunset. Heat built rapidly, from a distant warmth to a searing wave. The star's gravity asserted itself, pulling me in with relentless force. I was caught in its gravitational well, no turning back. The magnetic hum, oppressive red light, and rising heat overwhelmed my senses. Wolf 359 was no longer a distant object, but an environment of extremes. Life as we know it could never survive here. The faint glow became a raging inferno. I was about to plunge into the star's heart. The subtle welcome was over. The true nature of the red dwarf was revealed. I braced for the descent into chaos. The journey inward began. Entry into the chromosphere was a gradual transition into madness. I plunged into a sea of superheated hydrogen and helium, glowing with furious energy. Temperatures soared to thousands of degrees in an instant. My consciousness pressed onward, witnessing the impossible. The light was blinding, erasing all shadow and depth. Pressure mounted, the star's atmosphere pressing in. The roar of fusion thundered, a billion hydrogen bombs detonating every second. Flares erupted around me, magnetic fields twisting and snapping. I was engulfed in a storm of pure energy, senses overwhelmed. Gravity's pull intensified, plasma glowed brighter, and the descent continued. The fiery embrace was complete. The journey had only just begun. I plunged into the radiative zone where energy moves by photons in a cosmic pinball game. Surrounded by X-rays and gamma rays, the light became a searing white. Heat and pressure soared beyond comprehension, millions of degrees, crushing plasma. Here, the battle between fusion's outward push and gravity's inward pull raged. My descent slowed as if falling through glowing honey. I could no longer see, only feel the frantic dance of atomic nuclei. Pressure, heat, and light merged into a single overwhelming sensation. I became part of the star's consciousness, experiencing its existence from within. Approaching the core, I entered the furnace where nuclear fusion powers the cosmos. Hydrogen fused into helium, releasing the energy that fuels starlight. I witnessed the ultimate creation, the engine that keeps Wolf 359 burning. My journey ended in the core, my consciousness dissolving into the star's energy. Red dwarfs like Wolf 359 are the silent majority of the galaxy. They burn slowly, outliving most other stars by trillions of years. Their longevity offers immense timescales for life to arise, but their flares make survival difficult. Life here would need to be incredibly resilient. Falling into Wolf 359 revealed the universe's fundamental forces, gravity and fusion. Stars are not tranquil lights but dynamic, dangerous crucibles. Every atom in us was once inside a star. We are made of stardust. Red dwarfs will be the last lights in the universe, the final embers of a cooling cosmos. They are the slow, steady heartbeat of the galaxy.
ए ब्रो 1000 रुपीज का इंटरेस्ट आया है।
इतना तो मेरे स्लाइड सेविंग अकाउंट पर हर महीने इंटरेस्ट मिलता है।
यार आई इन्वेस्ट इन एफडी, एसआईपी, नो लोन्स, सेफ साइड पे हूं मैं, रिस्क नहीं लेना।
सेफ? तू अभी भी 2.75% पे खुश है?
सेविंग्स में इतना ही मिलता है, राइट?
तेरे अकाउंट में, मेरे अकाउंट में नहीं। आई यूज स्लाइस, मुझे मिलता है 5.5% इंटरेस्ट, वो भी आरबीआई के रेपो रेट से लेंगे।
व्हाट्स द कैच?
कोई कैच नहीं, कोई मिनिमम बैलेंस नहीं और कोई हिडन फी नहीं। ऐप पे सब दिख जाता है लाइव एंड इंटरेस्ट इज क्रेडिटेड ऑन डेली बेसिस। ऐसा लगता है पैसा मेरे से ज्यादा हार्ड वर्किंग है।
ब्रो लिंक भेजना, मैं आज ही खोल रहा हूँ।
करती हूँ ना।
Have you ever looked up at the night sky and wondered about the stars? They seem like tiny, glittering points of light, but they are so much more. Each one is a sun. A massive ball of glowing gas, incredibly far away. One of these stars is particularly special to us. It's called Proxima Centauri. Proxima, meaning nearest in Latin, the closest star to our sun, a cosmic neighbor across an incomprehensibly vast expanse of space, a constant source of curiosity for astronomers and dreamers, a tantalizing destination just beyond our reach. For centuries, humanity has gazed at the cosmos. We've sent probes to planets in our solar system, but the stars have remained distant dreams. Proxima Centauri becomes the first star we think about visiting. What would it be like? So, let's begin this grand imaginary adventure into the fires of our nearest stellar neighbor. The first thing we must comprehend on our journey is distance. The distances in space are simply staggering, far beyond anything we can relate to in our daily lives. Proxima Centauri is about 4.2 light-years away. That sounds simple enough, but a light-year is the distance light travels in 1 year, which is nearly 10 trillion kilometers. So, our destination is over 40 trillion kilometers from Earth. To put that into perspective, the fastest spacecraft ever launched by humans would take tens of thousands of years to cover that distance. Our journey, therefore, must be one of the imagination, a mental leap across the void. Let's imagine we have a fantastical spacecraft, one that can travel at nearly the speed of light, folding space and time to bring us to our destination. As we leave our solar system behind, the sun shrinks to become the brightest star in the sky, then just one among countless others. The journey would be long and dark, with the constellations shifting around us as we move through the galaxy. We are crossing an empty chasm between suns, a region of near-perfect vacuum, cold and silent. For years we would travel with the faint reddish dot of Proxima Centauri slowly growing brighter in our viewports. Finally, after our long voyage, we would arrive. The Alpha Centauri system would dominate the view. But our target is their dim companion Proxima Centauri. It wouldn't look like our sun. Instead, it would appear as a deep, angry red orb, much smaller and fainter. It's a red dwarf. Red dwarfs are the most common stars in the Milky Way, but so small and dim we can't see them from Earth. Proxima Centauri has only about 1/8 the mass of our Sun and is much smaller and cooler. What makes a star and not a planet? The answer? Nuclear fusion. At a star's core, the pressure and temperature are insanely high, crushing atoms together. Lighter elements like hydrogen fuse into heavier elements like helium. That fusion releases huge energy as light and heat. This energy pushes outward against gravity, keeping the star stable for billions or even trillions of years. Proxima Centauri burns fuel much more slowly and at a lower temperature than our Sun. Red dwarfs can be violent too. They are flare stars, able to suddenly erupt with bursts of energy and radiation. Now, our fall accelerates. We cross the point of no return. As we get closer, the first thing we would notice is the overwhelming light and heat. Even though Proxima Centauri is cooler than the Sun, cool is a relative term. The temperature rises to thousands of degrees Celsius. Our imaginary spaceship would not simply melt, it would vaporize. And honestly, our own body would not simply melt, it would vaporize. Every solid material would turn directly into gas. The light would be blindingly intense, a sea of red that would overwhelm any sensors or eyes. The next force to contend with is gravity. Proxima Centauri is less massive than the Sun, but it is also much denser. As you fall, the gravitational pull would become immense. You would experience something called tidal forces. The part of your body closer to the star would be pulled much more strongly than the part farther away. This difference in gravitational pull would stretch you out, a process gruesomely nicknamed spaghettification. Your body would be elongated into a thin stream of atoms. You would cease to be a person and become a ribbon of matter. Let's imagine you could somehow survive the heat and tidal forces. What would you touch? A star doesn't have a solid surface like a planet. It has a photosphere, which is the visible surface we see. It's a layer of dense, glowing gas. Below the photosphere, the journey continues into the star's interior. Here, the pressure and temperature climb to millions of degrees. You are now just a collection of atoms, stripped of your electrons, becoming part of the plasma of the star itself. You would be swept along in massive convection currents, giant rolling flows of hot gas rising from the core and cool gas sinking from the surface. Deep inside Proxima Centauri and its core, the conditions are unimaginable. The pressure is billions of times greater than on Earth and the temperature is millions of degrees. Atoms that once made up our imaginary traveler would be subjected to nuclear fusion. Hydrogen nuclei from the water in your body would be stripped bare, then slammed together with other nuclei to form helium. You would become fuel for the star, your matter converted into the energy that makes it shine. It's the most complete form of recycling in the universe. This thought experiment makes one thing clear. Falling into a star is not survivable. There's no technology we can imagine that could protect a person from such extreme forces. Intense heat, overwhelming radiation, crushing gravity, extreme pressures. We are beings made for the gentle, stable environment of a planet's surface. Stars operate on a different level of physics, fundamentally hostile to life as we know it. They are the givers of life, but only from a great distance. When we compare Proxima Centauri to our Sun, we see both similarities and differences. Both are fusion-powered, providing light and warmth. Our Sun is much larger, hotter, brighter. Our Sun will burn out in another 5 billion years. Proxima Centauri will continue to glow for trillions of years long after our galaxy has changed beyond recognition. In the end, stars like Proxima Centauri represent the profound duality of the cosmos, safe on our small blue world looking out at the cosmic fires from a respectful distance.
सप्लीमेंट सर नो इट ऑल वाले इन्वेस्टर्स के लिए नो नथिंग वाले इन्वेस्टर्स के लिए एंजल वन फॉर एवरीवन 3 करोड़ इंडियंस की तरह आप भी शुरू कीजिए एंजल वन फॉर एवरीवन
Investments in securities market are subject to market risks. Read all the related documents carefully before investing.
जल्दी जल्दी पेमेंट कर देती हूँ 60% ऑफ तो बिल्कुल मिस नहीं कर सकती Add to cart, payment OTP and what? Payment declined. Insufficient funds. अबे यार क्या 500 रुपए भी नहीं है मेरे पास?
Have you ever looked up at the sky and wondered, what if, in the blink of an eye, our sun vanished, and in its place a completely different star from a far-off, unknown universe appeared? Imagine waking up not to the familiar warm glow of our yellow sun, but to the fierce blue-white glare of a supergiant, or perhaps the dim red glimmer of a tiny dwarf star. This isn't just a fun thought experiment, it's a journey into the heart of what makes our world, our home, possible. The universe is filled with countless stars, each with its own story. Swapping ours would rewrite our story completely from the first page to the last. Our connection to the sun is the most fundamental relationship we have. It's more than just a bright light in the sky, it is the engine of our world. Think about it. The sun's gravity is the invisible hand that holds Earth in its perfect orbit, preventing us from spinning off into the cold, dark emptiness of space. It's a cosmic dance, and the sun is our partner, leading us through the seasons year after year. So what would happen if this cosmic engine was suddenly replaced? The consequences would be immediate and catastrophic, or perhaps just deeply, deeply strange. We are about to explore this cosmic swap. Let's journey to alternate realities where Earth orbits a new alien sun. Prepare yourself. The universe is about to get very, very different. Our sun is a star. A very special star, at least to us. It's classified as a yellow dwarf. It might sound small, but it's the perfect size for us. Burning steadily for about 4.6 billion years, with enough fuel to keep going for another 5 billion. This stability is key. It's like having a perfectly reliable furnace for our entire planet. It doesn't burn too hot, it doesn't burn too cold. This consistency has allowed life on Earth to evolve over millions of years, adapting to a predictable cycle of day, night, and the gentle rhythm of the seasons. Our sun is, in a word, dependable. The sun works through nuclear fusion. Deep in its core, pressure and temperature are immense. Hydrogen atoms squeeze together into helium. That releases an incredible amount of energy. Energy travels from core to surface, then radiates into space as light and heat. This is sunlight. Every second the sun converts millions of tons of matter into energy, a gigantic natural nuclear reactor at the center of our solar system, providing the power for everything we know and are. This solar energy does more than give light and warmth, it drives our planet's systems. Heat evaporates water from the oceans, which forms clouds, which returns as rain, creating rivers and lakes. It powers wind across continents. Let's perform our cosmic swap. First, we replace our sun with a blue supergiant, a true monster of the cosmos like the star Rigel. These stars are dozens of times more massive than our sun, and can be hundreds of thousands of times brighter. The moment it appeared, our sky would be filled with a blinding blue-white light. The concept of day would become an assault on the senses. The sheer intensity of the light would be unlike anything we have ever experienced. It would be brighter than a welder's torch everywhere all at once. Night would offer no escape, as the new star's light would likely be bright enough to read by even on the dark side of the Earth. The heat would be even more devastating. A blue supergiant burns incredibly hot, emitting vast amounts of ultraviolet radiation. The temperature on Earth would skyrocket. Our oceans would begin to boil, sending massive clouds of steam into the atmosphere. This would create a runaway greenhouse effect, trapping even more heat. Within a very short time, the surface of our planet would become hotter than an oven. All life on the surface, plants, animals, and people, would be scorched away. Our green and blue world would be sterilized, transformed into a barren, rocky wasteland like Venus, but worse. And then there's the gravity. A star so much more massive than our sun would exert a much stronger gravitational pull. Earth would be yanked from its stable, nearly circular orbit. We would be pulled into a new, much closer and faster path around the stellar behemoth. Our year might shrink to just a few weeks or even days, but we wouldn't be around to experience it. The immense gravity could also create powerful tidal forces, stretching and squeezing our planet. This could trigger massive earthquakes and volcanic eruptions on a scale never before seen, tearing the planet's crust apart from the inside out. Now for a different swap. Let's replace our sun with a red dwarf, the most common type of star in the universe. Imagine a star like Proxima Centauri, our closest stellar neighbor. These stars are tiny, often less than half the size of our sun, and much, much dimmer. If one suddenly appeared where our sun used to be, our world would be plunged into a perpetual twilight. The sky would lose its bright blue color, replaced by a dim, reddish-orange glow. The new daylight would be no brighter than the light we see just after sunset on a clear evening. The world would become a place of shadows. The drop in heat would be immediate and severe. A red dwarf emits only a tiny fraction of the energy our sun does. Earth, at its current distance, would quickly freeze. The average temperature would plummet far below zero, and a new ice age would begin, but one from which we would never recover. the oceans would freeze over, starting at the poles and spreading to the equator, entombing our planet in a global sheet of ice. But this creates a new problem: tidal locking. Our planet would become locked in its orbit. One side of Earth would permanently face the red dwarf, the other side would be frozen in eternal night and darkness. A thin strip of land between these two extremes, a twilight zone, might be the only place where liquid water could exist. What if we swapped our sun with something truly bizarre, something from the pages of science fiction? Imagine a pulsar taking its place. A pulsar is a type of neutron star, the super-dense, collapsed core of a massive star that exploded. A pulsar also spins rapidly, sometimes hundreds of times per second, sweeping beams of intense radiation across space like a cosmic lighthouse. Or consider a binary star system, where two stars orbit each other. Let's say our sun was replaced by a pair of suns. Let's push the boundaries even further. What if our new sun was a black hole of the same mass as our sun? Thinking about these scenarios reminds us of how incredibly fortunate we are. Our sun, our simple yellow dwarf, is the perfect star for us. It is the right size, the right temperature, and the right age. It provides the stability and energy that life needs to flourish. The universe is filled with countless stars, terrifying giants, dim dwarfs, and exotic cosmic wonders. We won a cosmic lottery. So, the next time you feel the warmth of the sun on your face, take a moment. Appreciate that steady, life-giving light in our sky. And perhaps just for fun, imagine what it would be like to look up and see a completely different sun shining down on you.
पत्नी अपने पहले प्यार के साथ 3 दिन और 3 रात बाहर रही। पति को बिल्कुल गुस्सा नहीं आया। उल्टा उसने उसके कपड़े भी
Have you ever gazed up at the night sky and wondered about the stars twinkling back at you? Each one is a sun, a colossal ball of fiery gas burning trillions of miles away. Now let's take that wonder a step further. What if you could fall into one? Not just any star, a K-type main sequence star, also known as an orange dwarf. It's a journey no human will ever take, a purely hypothetical plunge into one of the most extreme environments the universe has to offer. This isn't about surviving, it's about understanding the sheer, untamed power of the cosmos. The idea sounds straight out of science fiction. We picture space as cold and empty, but a star is the complete opposite. It is a place of unimaginable heat, crushing pressure, blinding light. To even approach such a body would be an odyssey of epic proportions, a one-way ticket to the heart of creation and destruction. As you begin this imaginary fall, you would witness spectacles beyond human comprehension, the fabric of space and time seeming to warp around the star. The laws of physics we know would be twisted into extreme and violent forms. This thought experiment is more than morbid curiosity. By exploring this impossible descent, we can peel back the layers of a star and appreciate its structure and function. What forces are at play? What makes a star shine? How does it hold itself together against its immense gravity? Before we can appreciate the full intensity of our fall, we need to understand our destination. A K-type main sequence star is a fascinating celestial object, often called an orange dwarf. Main sequence means it's in the most stable, longest phase of its life, steadily fusing hydrogen into helium in its core like our sun. They're the universe's middle children, positioned between G-type yellow stars, like our sun, M-type, the smaller, cooler red dwarfs. Here's how red, orange, and yellow dwarfs compare. Their orange hue comes from surface temperatures typically around 3,900 Kelvin up to about 5,300 Kelvin. What truly sets K-type stars apart is their incredible longevity and stability. Our sun has a total lifespan of about 10 billion years. A K-type star can burn steadily for 15 to 70 billion years. That's a timescale so vast it dwarfs the current age of the universe, about 13.8 billion years, which means almost every K-type star that's ever formed is still shining today. Their slow, methodical fusion makes them incredibly reliable, producing consistent energy without the violent flares common to red dwarf cousins. In size and mass, they're in a cosmic sweet spot, typically between 0.6 and 0.9 times the mass of our sun, big enough to host planetary systems but not so massive they burn out fast. Their luminosity is less than the sun's but more than a red dwarf's. That creates a wider, more stable Goldilocks zone. Let's start with what we know best, our own sun, a G-type star. The sun is a vibrant yellow-white star, a powerhouse of energy. It has nurtured life on Earth for billions of years. However, it is relatively short-lived in the grand cosmic scheme. The sun is more massive and burns hydrogen much more rapidly than a K-type star. Now the other end, M-type stars, red dwarfs. They are the most common stars, about 75% of the galaxy. much smaller, cooler, and far dimmer than K-types, leaving planets tidally locked, one side always day, the other always night. They also flare violently, blasting nearby planets with sterilizing radiation. Enter the K-type, our Goldilocks candidate. It avoids those extremes. An orange dwarf is the happy medium. Now, the moment of truth. The imaginary journey begins. Long before you reach what could be called the surface, your fate is sealed. Thousands of miles out, the heat would be utterly overwhelming. The star's radiation, a torrent of high-energy photons from its core, would bombard your vessel and your body. Temperature jumps from hundreds to thousands of degrees Celsius in mere seconds. Any conventional material would vaporize instantly. Your body, mostly water, would flash into steam before you can register burning. Assuming you survived the heat, next comes the star's immense gravity. A K-type star is smaller than the Sun, but packs nearly the same mass into a tighter volume. As you fall closer, gravity becomes extreme. Tidal forces would stretch you, spaghettification. There is no solid surface to land on. A star isn't a solid ball, it's a sphere of plasma, a superheated state where electrons are stripped from atoms. You plunge through the chromosphere, then the photosphere, a churning, convective sea of incandescent gas. Hydrogen nuclei slam together and fuse into helium. In this crucible, anything that was you is utterly obliterated, your mass converted into a fleeting burst of energy that feeds the star's glow. After surviving our harrowing and thankfully imaginary plunge, one big question remains. Why are we so fascinated by these orange dwarfs? The answer isn't their fiery interior, it's the gentle, life-giving potential for their planets. K-type stars are the marathon runners of the cosmos. They can live for up to 70 billion years. That gives an enormous window for life to arise and evolve. Complex life on Earth took nearly 4 billion years to develop. On a planet around a K-type star, evolution would have an even longer, more stable runway. They emit a steady stream of light and heat, creating a predictable, nurturing environment. Combine these and K-type stars emerge as prime targets for SETI and habitable exoplanet searches. Telescopes like the James Webb Space Telescope are focused on them. They are the true Goldilocks stars, not too hot, not too cold, and they last for a very, very long time. Keep looking up and never stop asking what if. If you enjoyed this cosmic journey, check out my profile for more mind-bending content. And don't forget to explore AI Media Machine, the all-in-one platform to create 50+ pieces of professional content per week.
నువ్వు నిజంగా వీరుడివి అయితే 100 సంవత్సరాలుగా ఎవ్వరూ తీయలేకపోయినా పాతాళ లోకంలో క్రూర మృగాల అదుపులో ఉన్న ఆ వజ్రాల కత్తిని తీసుకొనిరా. ఆ మరుక్షణమే నా యువరాణి కిరీటాన్ని.
What if every single asteroid in our solar system suddenly fell toward Earth at once? Would it destroy us instantly? Could the planet even survive?
That's one of the most terrifying what-ifs in the universe. Right now, there are millions of asteroids orbiting between Mars and Jupiter, some the size of mountains, some larger than entire cities. Now imagine, all of them changing course, straight toward us.
So what happens first?
At first nothing. You'd look up and see the night sky, then realize the stars are moving. Dozens of bright lights streaking through the atmosphere. Within minutes, the skies ignite, temperatures rise, satellites fry, and the upper atmosphere bursts into fire. The smallest asteroids would hit first, burning through cities, oceans, and forests like bullets through paper.
Would it all happen at once?
Almost. The planet would experience billions of impacts per minute, every explosion larger than a nuclear bomb. Oceans would boil, shockwaves would circle the Earth non-stop, the air itself would turn into fire.
Could anything survive that?
No, not humans, not animals, not even bacteria. When hundreds of massive asteroids, each the size of Everest, hit simultaneously, the Earth's crust would start melting. The surface temperature would exceed that of the sun's corona. Mountains would flatten, continents would vaporize, and the oceans, they'd turn into superheated steam.
Would Earth itself break apart?
It's possible. The combined kinetic energy of every asteroid in the solar system is enough to shatter the Earth's crust, split the mantle, and fling fragments into space. Some scientists believe the planet might be reduced to a glowing ball of molten rock, or even torn into a new asteroid belt. Basically, Earth would stop being a planet.
So what would be left?
Silence. No atmosphere, no oceans, no cities, just fragments of metal and molten rock orbiting the sun, a graveyard of what used to be home. It would be like Earth never existed. Ironically, the very asteroids that once helped create the building blocks of life would end it in the most brutal way possible.
So, is there anything we can actually do if one huge asteroid heads our way?
That's the good news. NASA's already testing kinetic impactors, spacecraft designed to slam into asteroids and knock them off course. We might not stop everyone, but maybe, just maybe, we can stop the next one. So next time you look up at the night sky, remember, space isn't peaceful, it's quiet, because everything dangerous is still waiting to fall. And speaking of survival, if you're building something online and want to stand out before it's too late, there's a new content creation tool that's exploding right now. It's helping influencers, businesses, and creators dominate their niche faster than ever. It's selling out fast, so click the link in bio and grab it before everyone else does.
What if you started shrinking at a rate of 1 centimeters every second? Picture yourself standing tall, but as the seconds tick by, the world around you seems to grow. Suddenly, objects that once felt commonplace loom ominously larger. The narrator's voice cuts through the tension, explaining how this phenomenon would uniquely alter your perception of reality. How would daily activities feel when your height diminishes? Imagine reaching for a doorknob that now hangs high above. Each mundane task transforms into a mini-adventure as the challenges intensify. The narrator interjects with fascinating insights into the obstacles you would encounter, like navigating streets and finding transportation, all becoming giant hurdles in your life. What impacts would this constant shrinking have on your social interactions? Picture yourself at a gathering, and as you shrink, your friends tower over you, their laughter echoing as your stature continues to diminish. The narrator highlights the psychological aspects, discussing how your confidence could wane and how friendships might evolve. Emotions swell as you come to terms with this bizarre new existence. What would happen if your shrinking continued indefinitely? The possibilities are astounding. Eventually, you might be smaller than an ant, navigating the colossal terrain of your home with a newfound appreciation for the miniaturized world. The narrator's voice captures the wonder of this perspective shift, opening your eyes to details you might have overlooked before. And amidst these thought-provoking questions, there emerges another topic. Imagine a world where such scenarios could become captivating content for social media pioneers. As the narrator shifts gears, he introduces an innovative content creation tool designed for influencers, businesses, e-commerce, and more. This tool sparks creative ideas and elevates online presence effortlessly. So how can you harness such creativity? With just a click of the link in the bio, you can access this powerful tool that promises to revolutionize your content game. The urgency builds. This exclusive offer is flying off the virtual shelves fast. Don't miss out on utilizing the very tool that can help you thrive in the digital landscape, making your brand uniquely captivating.
What if you could ride the cosmic wave and fall into the luminous depths of Canopus, the second brightest star in the night sky? A light year ahead, this magnificent white supergiant beckons, a celestial beacon brighter than almost everything else surrounding it. Imagine yourself inching closer to this stellar marvel, curiosity resonating in your very being as the universe itself unfolds its secrets before you. Approaching Canopus feels otherworldly. The dark expanse of space bursts to life with a scintillating brilliance. Radiation emanates from the star, far exceeding the boundaries of human endurance. Your spacecraft, gliding into this dazzling realm, becomes an object of fragility. As the light intensifies, it transforms into a force of nature, a relentless barrage of photons that dance towards you like ethereal warriors. The hull of your craft starts to shimmer, heat waves rippling across its surface, each pulse igniting your anticipation as the dream of exploring this titan star inches closer. Plunging into the heart of Canopus is not a mere leap. It is an immersion into a tempest of superheated gas swirling at a staggering 7,500 Kelvin. The distinction between solid and liquid fades away as you plunge into this glowing chaos. You become part of an eternal mechanism, hydrogen transitioning into helium in a cosmic ballet, while titanic convection currents tower above. In mere moments, you marvel at the sight, only to find that your very essence is surrendering to the flames behind the brilliance. As you witness this stellar spectacle, you realize that Canopus is on a precipice of transformation. Its core, straining under the weight of time, prepares for its next monumental change. The brilliance you adore bears witness to imminent evolution. Canopus will swell into a red supergiant, a prelude to a glorious collapse. The fusion dance, once harmonious, is now misaligned, setting the stage for a potential spectacular supernova, a vivid explosion of color that will echo through the cosmos for eons. You grasp the poignant truth. The end of such beauty begets new beginnings. In this dying light, the elements forged within Canopus will become the building blocks for future worlds. To journey through the radiance of Canopus is to embrace the cycle of existence itself, where brilliance, though fleeting, always illuminates the universe's fabric. As you drift to the precipice of creation and destruction, you understand. You are part of something larger, a vibrant saga written among the stars.
Imagine yourself adrift in the silent expanse of space. Your ship is gone. There is only you, your spacesuit, and the endless black. But ahead, a celestial object of impossible beauty and terror fills your vision, a Wolf-Rayet star. It pulses with fierce ethereal light, surrounded by a glowing nebula of its own making. You are falling toward it with no escape. The star is a turbulent sphere, its surface a chaotic tempest of stellar material violently ejected into space. Great arcs and plumes of incandescent gas, larger than planets, are hurled outward at incredible speeds. The colors are mesmerizing, turquoise, violet, the palette of raw, untamed power. You are a silent witness, a speck about to be consumed by a cosmic furnace. As you get closer, a strange pressure pushes against you, the stellar wind, a hurricane of atoms millions of times stronger than our sun's. It buffets your suit, a relentless cosmic gale. The scale is incomprehensible. You're falling into a storm billions of kilometers across, raging for millennia. Through your suit, you almost hear the stars roar, the sound of fusion and fury. The nebula glows with eerie light, illuminated by intense radiation. This cloud is the star's own outer layers, shed over thousands of years, a beautiful shroud for a dying giant. Now you're about to pass through this veil, entering the star's deadly embrace. Your final moments are a descent into a celestial masterpiece of terrifying grandeur. There is only awe, and the end. What is this magnificent beast? A Wolf-Rayet star is a fleeting, spectacular final stage in the life of the universe's most massive stars. Born with dozens of times the sun's mass, they burn through fuel at astonishing rates and shed their outer layers, exposing a super-hot helium-rich core. The exposed core blasts out intense radiation, creating phenomenal stellar winds, torrents of matter traveling thousands of kilometers per second. This violent outflow means Wolf-Rayet stars live fast and die young, lasting only a few 100,000 years. Inside, they forge elements heavier than helium, carbon, oxygen, and beyond. When they die, they explode in supernovae, scattering these elements across the galaxy. The carbon in your body, the oxygen you breathe, likely born in a star like this. Wolf-Rayet stars are incredibly hot, glowing blue-white or violet, and outshine thousands of suns. They are the universe's element factories, brilliant, chaotic, and destined for a dramatic end. Without them, the cosmos would be a much simpler, emptier place. They are the rock stars of the stellar world. Back to your fall, now through the nebula, facing the star's unshielded fury. Your suit's electronics fail instantly, overwhelmed by radiation and magnetic fields. The stellar wind becomes a physical wall, eroding your suit atom by atom. Heat skyrockets. Your suit melts and vaporizes. Life support fails. The water in your body flashes to steam. You are vaporized, disassembled atom by the star's energy. There is no solid surface, just denser and denser gas. As you fall, you merge with the star, your atoms stripped and turned to plasma. In less than a second, it's over. Your matter is swept into the star's turbulent currents, dragged toward the core. There, immense pressure and temperature break you down, forging your atoms into heavier elements. You become part of the star, a brief, silent dissolution. In a strange, poetic way, you are recycled in the heart of a stellar giant. You are one with the cosmos. The forces at play are staggering. A Wolf-Rayet star can be over 20 times more massive than our sun, but its luminosity is millions of times greater. If our sun were replaced by one, Earth would be instantly sterilized, oceans boiled, surface scorched. The stellar wind is mind-boggling. These stars lose mass at a rate that would equal the sun's entire mass in just 100,000 years. This outflow enriches space with heavy elements, seeding future stars and planets. The wind can reach thousands of kilometers per second, over 10 times faster than our fastest spacecraft. It carves vast bubbles in interstellar gas, shaping galaxies. When fusion in the core ends, the star collapses and explodes as a supernova, briefly outshining its entire galaxy. The explosion scatters elements across space, leaving behind a neutron star or black hole. Wolf-Rayet stars are engines of cosmic change. Falling into a Wolf-Rayet star means total, instantaneous annihilation. There's no drama, just a moment of overwhelming beauty, then erasure. Yet in this violence, there's profound beauty. These stars are the universe's great sculptors, forging the elements of life. Without them, there would be no carbon, no oxygen, no stardust for planets or people. Our existence is tied to their demise. Wolf-Rayet stars remind us that creation and destruction are inseparable. We are, quite literally, children of the stars. The universe is not just stranger than we imagine, it's stranger than we can imagine.
All-in-one DMAT with multiple benefits. Open your free DMAT account now.
Investment in securities market are subject to market risk. Read all the related documents carefully before investing.
LTP देखना is not enough. LTP क्या होता है? सिर्फ उस मोमेंट का प्राइस.
Imagine just for a moment that you could fall into a star. Not just any star, but a colossal, fiery giant named Betelgeuse. This isn't a gentle dip into a warm pond. It's a cosmic plunge into one of the most extreme environments in our galaxy. Forget everything you know about falling. Gravity here isn't just a force. It's an all-consuming destiny pulling you toward a magnificent, terrifying heart of fire. We're about to embark on a journey that no human could ever survive, but one that our minds, fueled by curiosity and science, can explore. So buckle up your imagination. We're heading for the shoulder of the giant, the constellation Orion, to meet this stellar celebrity up close. It's a one-way trip, but the view is, quite literally, out of this world. Betelgeuse isn't your average everyday star like our sun. It's a red supergiant, a true behemoth of the cosmos. Located about 650 light-years away, it shines with a distinct ruby-red hue in our night sky, marking the right shoulder of the hunter, Orion. What makes it so special? Its sheer size. If you were to swap our sun with Betelgeuse, its surface would extend past the orbit of Mars and maybe even Jupiter. That means Earth, Venus, Mercury, Mars would all be inside the star. It's a cosmic beach ball compared to our sun's tiny marble. This star is in the twilight of its life, puffed up and bloated, getting ready for its final, spectacular act. It's a senior citizen of the stellar world, and it's not going out quietly. So what would happen if you actually fell in? Let's start our journey from a safe distance, say a few million miles away. Even here, the sheer scale of Betelgeuse would be incomprehensible. It wouldn't look like a point of light. It would fill your entire view, a colossal, boiling sphere of ruddy light. You would feel its heat immediately, not as a gentle warmth, but as an intense baking radiation. Your spacecraft and you would need impossible levels of shielding to survive even for a second. The star wouldn't appear as a perfect smooth ball either. Its surface is a turbulent, churning mess of massive convection cells, like bubbles in a pot of boiling soup, each one larger than our own sun. The very color of Betelgeuse tells a story. Why is it red? It's all about temperature. Hotter stars, like our sun, or the brilliant blue Rigel, burn with a white or blue-white light. As our imaginary journey continues, we push closer, crossing the threshold of what we might call its surface. But Betelgeuse doesn't have a solid surface like Earth. It has a photosphere, a region where the gas becomes opaque, but it's incredibly diffuse and fuzzy. Think of it less like hitting a wall and more like flying into a thick, fiery fog. The density here is actually less than the air we breathe on Earth, but the temperature is apocalyptic. Before you could even register what was happening, you and your ship would be atomized. The intense heat and radiation would rip apart the bonds holding your molecules together, turning you into a cloud of glowing plasma in less than a blink of an eye. There's no feeling the heat, you simply cease to exist as a solid object. Let's press on with our ghost-like, indestructible selves. As we drift through this outer layer, the view would be an awe-inspiring nightmare. We are now inside the star. All around us are vast, rising plumes of superheated gas, each one the size of a planet. These are the convection currents carrying energy from the star's interior to its surface. The light isn't coming from one direction anymore, it's everywhere. We have now traveled thousands, perhaps millions of miles into the star. The journey is nearing its end. Ahead lies the core. This is the star's final frontier, a place of such extreme density and temperature that the laws of physics as we know them are pushed to their limits. The core of Betelgeuse is no longer fusing light elements, it's now creating much heavier things: neon, magnesium, silicon. The temperature here reaches billions of degrees. The pressure is so great that matter itself behaves in strange ways. Electrons are stripped from their atoms, creating a sea of degenerate matter where particles are packed as tightly as nature allows. As we approach this final destination, the force of gravity becomes almost infinite. Time itself would begin to distort just as Einstein's theories predicted. For us, the final plunge might seem to take an eternity, while for an outside observer, it would happen in an instant. The core isn't a vast space. For a star as big as Betelgeuse, its final iron-rich core might only be the size of Earth. All the mass of this supergiant star is crushing down on this tiny, incredibly dense ball. It's a gravitational vice of cosmic proportions, and then we arrive. The core of Betelgeuse is where its story will end. So, what's the point of this imaginary and utterly fatal journey? We can't actually fall into a star, but using the laws of physics to guide our imagination, we learn something profound about our universe and our place in it. These extreme thought experiments let us explore realms far beyond our physical reach. They turn abstract numbers into a visceral experience: temperature, pressure, size. Thinking about falling into Betelgeuse helps us feel the sheer scale and power of the cosmos. It reminds us that our planet is a fragile, precious oasis in a universe of beautiful, violent extremes. This journey teaches us about our origins. Betelgeuse forges heavy elements in its core. It's not just trivia, it's the story of us. The iron in your blood, the calcium in your bones, none of it existed at the universe's birth. Iron in your blood, calcium in your bones. Those elements were manufactured inside massive stars that lived and died long before our sun. Looking at Betelgeuse is looking at the stellar factory that made the raw materials for our solar system. We are, as Carl Sagan said, made of star stuff. Studying stars like Betelgeuse reveals the universe's life cycle. Stars are born from clouds of gas and dust. They live for millions or billions of years and then they die, sometimes in a spectacular supernova. This cycle, birth, life, death, is a fundamental cosmic process. In the end, curiosity is our greatest tool. We may never visit another star, but our minds can reach them.
अब ट्रेड के लिए दोस्तों से उधार मांगने की जरूरत नहीं है। IND मनी में 1000 रुपए से भी 5000